Hello, welcome back. Today we are going over the third part of the first EOG review. That's the end of grade review. Not saying that we are having an EOG this year because, well, figure it out. Anyways, 23. 23, this is a percent problem, so we need to set it up as a percent problem. That is, we're going to use the is over of equals percent over 100. Part over total equals percent over 100. Now, it says George spent 80% of his savings to buy a camera. Okay, the camera cost $580. So, that $580 is the 80%. So when we replace everything in our problem, 80% goes here, and we have 580 up here. This we do not know. We don't know what that's going to be. So, to solve this problem, we're just going to cross multiply by what we can, and then divide by whatever number we have not used yet. So, my problem is going to look like this. We are going to do 580 times 100, so 580 times 100, which gives me 58,000, but then we're going to divide by 80. So we're going to take that and divide by 80, and that gives me 725. That is how much money he had before he bought the camera, according to this problem. Moving right along. We're going to do... Whoop, that's the wrong one. That's still the wrong one. There we go. Number 24. For number 24, it says, guests must be at least 42.5 inches tall to go on the amusement park ride. Which inequality represents the heights, h, in inches, of the guests allowed to ride? So, for this one, it says guests have to be at least 42.5 inches. So, first question, can somebody be exactly 42.5 inches tall based on this? Guests must be at least 42.5. That means, yes, they can be equal to this. So we need this symbol. We need the one that says greater than or equal to. This just says greater than. That's not what we want. And then, obviously, we want it comparing 42.5. So they can be 42.5 inches tall. They don't have to be exactly 43 inches. That's not quite right. Moving on from number 24, we have 25, which says which expression is equivalent to A plus A plus A plus B plus B plus B. So let's just see. We've got 1A plus 1A plus 1A. What is that? That's 3A. We have 1B plus 1B plus 1B. What is 1B plus 1B plus 1B? 3B's. That's all. You can't get 6AB. 6 should not be part of this problem, which is what some of you may have been tempted to do, and it may have stumped you that that wasn't an answer choice. So yeah, 25, this is all you do. Those won't work. None of those. No. Alright, number 26. For number 26, somebody is revving their engines outside my house, and I don't like that. Grr. Alright, get that pen out of the way. Number 26, Jackson sells fruit at the farm stand. This week, he is offering free pears to customers who buy apples. The ratio of the number of apples that are bought to the number of pears Jackson includes for free is shown in the table below. So we've got 6 apples, 2 pears. 12 apples, 4 pears. 15 apples, question mark pears. 27 apples, 9 pears. 30 apples, 10 pears. And our goal here is to figure out that question mark. If somebody buys 15 apples, how many free pears do they get? What we're looking for is we're looking for the relationship between the top and the bottom number. How do we get this bottom number? How do we go from 6 to get 2? How do we go from 12 to get 4? What is happening when we're doing that? The answer lies in either multiplication or division. Whenever you see ratio tables, think multiplication or division. Somehow we multiplied or divided 6 by something to get 2. And we do the same thing for 12, 27, and 30. It's most obvious what we're supposed to do here and here. How do I go from 6 to get 2? How do I go from 30 to get 10? The answer is you're dividing by 3 for each part. Whenever I go from 6 to 2, I'm doing 6 divided by 3. 12 divided by 3 gives me 4. 27 divided by 3 gives me 9. 30 divided by 3 gives you 10. So all you have to do here is do 15 divided by 3, and you'll get your answer here. When you do 15 divided by 3, you should get 15. As 15. Can't speak. You should get 5 as your answer. Moving right along. Number 27, which is, I'm going to have to probably zoom out a little bit on my camera in order to see this problem. There we go. Number 27. The dot plot shows the number of hours 2 groups of students spend online each week. Group A, Group B. Which statement correctly compares the data? Okay, so this is number 27. We want to find which one compares these data points better. A says the measure of center are closer for each other for Group A than Group B. Now, what this says, if it says the measure of center is closer for Group A, that means that the data is not very spread out. I mean, look at it. You would be hard-pressed to make that data even more spread out, so it's definitely not A. That's kind of backwards. For B, the measures of center are higher for Group A than Group B. That doesn't really seem true because just kind of looking at this, it looks like most of the data is way down here, not like B, which is a lot higher up. So B seems backwards to me. C says the variability of Group A is greater than the variability of Group B. This is a new word for some of you. If you're in my honors class, we did talk about this a couple of times during the Core Bytes. We have talked about this during the Core Bytes before, but this is statistics, so not everybody made it to this before all this quarantine stuff. But variability means to be spread out. Variability means to be different, to be diverse. That's what that word means. Variability means spread out, and you can look and see, yeah, that is true. Group A does have greater variability. It is more spread out than Group B. Group A starts at 0 and ends at 15. Group B starts at 5 and ends at 15. So yeah, that would mean A is more spread out. A has more variability. Number 28 will be next. 28. A rectangular prism is 5.5 inches long, 3 inches wide, and 3.5 inches high. What is the volume? Nice simple volume problem. These are the easiest kinds of problems to do. All you're doing is length times width times height. So, with this type of calculator, what you will do is look for that fraction button right there. You can go ahead and punch in your fraction using this to kind of navigate around it. So my whole number, 5, 1 over 2, get out of the fraction, times 3, times, we need a fraction again. It's going to be 3.5, so whole number, and then 1/2. Now that gives you 231 over 4. Obviously, not an answer choice. For this, what you can do there's another button on this calculator you can use, which is actually a second button. It's right here. It's above this X10N button. In order to activate this teal or neon green, whatever you want to call it, color writing, you have to click the second button. So when you push the second button, your calculator will say second, meaning you've activated it. And now when you touch this button, it'll activate this stuff up above, which shows a regular fraction, 2 triangles, and then U and a fraction. That means it's going to take a regular mixed number, an improper fraction, and turn it into a mixed number when you push it. All those symbols will show up. You hit enter. 57 3/4. Alternatively, if you wanted to do this the old-fashioned way, you would just do 231 divided by 4, and that would give you the whole number amount. So we want 57 3/4. Boom. Done. Moving right along to number 29. The ratio of short sleeve shirts to long sleeve shirts in Sanja's closet is 12:7, which representation also shows the ratio of Sanja's short sleeve shirts to long sleeve shirts. So, for number 20, I keep wanting to say 27. For number 29, we are looking for something that is the same as 12:7. That's it. There is nothing special to say. All you are looking for is a different way to write this same ratio. 12:7, that can be written 3 ways. 12:7, 12:7, and 12:7. All 3 ways are exactly the same. This is the same as this, which is the same as this, which is the same as each other. Moving right along. Number 30. For number 30, the graph shows the distance of remote-controlled plane flies over time. Alright, there's our chart. And it says, if the remote-controlled plane always flies at the same speed, which coordinate pair could also be plotted on this graph? So what we're kind of looking for is we're looking to draw a straight line from 0 going through all of these points. So let me see about getting this lined up just right so I can draw a line. Ooh, not quite. Very close though. That's still not quite right. That's very close. Let me try that one more time. There we go. Alright. So, I mean, a little bit messy, but you kind of get the picture. You could do this the old-fashioned way and draw a line. Now, if that's not an option, another thing you can do is you can look and see, okay, I move 3 over and I go 3 up. And I move 10 over and I go 10 up. I am moving 1, 2, 3, 4, 5. It's going up in steps for this. So all you're really kind of looking for is a point that would match this same spot. The problem is that some of you might have seen that and thought, oh, but there's multiple answers. Both A and B work. Not quite. That says 2 to 20. Have you noticed what they're counting by over here on the side? They're not counting by 10s. They're counting by 20s. So 220 would actually be located here. And that's not on that line, clearly. So it's not A. They tried to trick you by doing that. B has the same problem. 550. Well, look where 50 really should be. Should be over here. So, no, that does not work either. For number 30, they were hoping you would look here. 6, 120. When you go 6 over, you go up. Well, you will go up 6 tick marks, which means you are counting by 20. So 6, and you're going up by 20. So 20, 40, 60, 80, 100, 120. This is where that point actually will lie. Everything else isn't actually going to be on that line. Number 31. Oop, can't see it. Camera has to move. The low temperature for Monday was negative 12 degrees Fahrenheit. The low temperature for Tuesday was 7 degrees Fahrenheit. Which statement is true? For number 31, option A says that the low temperature on Tuesday, 5 degrees, was 5 degrees cooler than the temperature on Monday. That is completely wrong. Tuesday is not cooler than Monday at all, so that is bogus. B says the low temperature on Tuesday was 5 degrees warmer than the low temperature of Monday. Well, let's see. What is the distance from negative 12 to positive 7? Well, let's see. I would have to go up by 12 just to get to 0 from negatives. And you can see that if we draw a number line. I'm going to borrow this space on my paper. I'm going to draw a number line. We're going to start at negative 12. So negative 12, negative 11, negative 10, negative 9, negative 8. And I think you get the picture. Negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. I don't think I needed to go that... Oh, I did need to go that high. Yeah. So on Tuesday, it was 7 degrees. So right here, that's Tuesday. And Monday was here. How far apart are they? How many spaces are between Tuesday and Monday? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 is the distance. So, I mean, B is partially right. It is warmer, but not by 5 degrees. C has the same problem as A. It says that Tuesday was colder. That's not right. Tuesday was the warmer day. Tuesday was 7 degrees Fahrenheit. Monday was negative 12. D is the one that is correct. It says that Tuesday was 19 degrees warmer than the low temperature on Monday. And based on our number line, that checks out. Moving right along to number 32. The length of a rectangle is represented with a line segment with endpoints at A, 0, 0, and B, 8, 0. The width of the rectangle is 1/2 its length. What is the area of this rectangle? Now, in order to do this problem, we're going to need some graph paper. I've already prepared some just for this problem. We've got point A at 0, 0. So point A is right here. And point B at 8, 0. 8, 0 would be located here. Point B. Now, it says that the width of this rectangle is 1/2 of its length. So first, we need to figure out how long is this rectangle. This rectangle is 1, 2, 3, 4, 5, 6, 7, 8 spaces long. So the width is going to be 1/2 of its length. So 1/2 of 8 is going to be 4. 1, 2, 3, 4. This is a reasonable space to put points, the remaining 2 points of this rectangle. The last step of this problem is it asks, what is the area of the rectangle? Well, we know that the base is 8. We know that the height is 4. So to find the area of a rectangle, we're just going to do base times height. So my area is just going to be 8 times 4. So my area is 32 units squared. 32 units squared. Well, square units, units squared, same thing. Moving on to number 33. The table shows the number of pages Brian's printer can print in different amounts of time. So 12 pages, 5 minutes, 36 pages, 15 minutes, 60 pages, minutes, and so on and so on. How many minutes does it take Brian's printer to print 60 pages if it continues to print at the same rate? Alright, so for this problem, it's kind of hard to tell based on a different problem where we had another table. You could kind of see, alright, I'm dividing the top number by something in order to get the bottom number. That can work here. Okay? You could say, alright, 12 is being divided by a certain fraction in order to get 5. The easier way to find this out, though, is to set up an equivalent ratio. Meaning, you could just look at that and say, alright, 36 pages in 15 minutes should be the same as 60 pages in we don't know how many minutes. This is the way we have set up all of our percent problems and all of our unit rate problems, so this should be pretty familiar. Once you've set it up, you're going to cross multiply 60 times 15, and then you will divide by whatever has not been used. With a calculator, this question is child's play. You're just going to go ahead and do 60 times 15, and then divide that by 36. 25. Done. With a calculator, this type of problem is a non-issue. And I should point out, darn near all of these types of problems, actually, let me rephrase that, all of the unit rate problems and percent problems are in the calculator active unit. So don't worry about it. Just make sure you remember how to set up these problems. If you don't remember this setup, well, the calculator is not going to remind you. Alright, last one for now. We've got 4 people spending the day together collecting cans for recycling. By lunch, they have a total of 173 cans. At the end of the day, the total number of cans collected can be represented by 173 plus n. So, what on earth could n possibly represent? It just says, by lunch, they collected 173 cans. So what could n be? A says, the number of cans all 4 collected the next day. That is possible, but it says that they are just spending the day together. So I'm going to rule that out, although that isn't a bad answer. I already don't like this question. B says the number of cans all 4 collected during and after lunch. That's possible, because this says by lunch they collected that much. So it stopped. They stopped counting here when it was lunchtime. So it could very well be the amount they collected during and after lunch. B, C, and D, the problem there is they're only accounting for one person. So yeah, this problem really isn't super great. Not a huge fan of it. You could argue that it could be collected the next day. I'm not saying you couldn't. I'm not saying it's impossible. But, well, I have the answer key off to the side, just off camera where you can't see it. So, the answer is supposed to be B. And that's all for now. I guess go ahead and give that quiz a second try now that you have seen the answers and seen the explanations. Go ahead and give it another shot. Good luck.